Today we're going to review solving inequalities as a skill, and we've done everything that we're going to do in today's lesson this year in some context. And I want you to, we're going to introduce one new thing to this, and because you'll see this in Algebra 2. This will be something that you see a lot in Algebra 2, so I want you to see it now. You may not remember it then, but it'll come back quicker if you've seen it before. And that's interval notation. I'm probably not going to quiz or test on this, but I want you to see it. Okay? All right. So, solving inequalities is the same as solving equations except for what?
There's a greater than or equal to sign.
Right? We have inequality symbols instead of equal signs. What else is different?
We graph it.
You can graph your answers. That's correct. So the way we express our answers can be different. It has more than one answer, right?
Kind of, yeah.
X is less than 5, for example, has an infinite number of solutions, whereas an equation would just be like X equals 5. We just have one thing. All right. All right, so solving inequalities is different in that we can have our answer expressed as a number line. We can have infinite number of answers to inequalities, whereas equations just have one or none. What else is different about the process of solving inequalities?
Divide by a negative number.
If you divide by a negative number, you have to reverse the symbol. Okay? So that's right. In graphing it, we can express the answers in different ways. So if we divide by a negative number, we're going to get, we must reverse the inequality symbol. Whenever we multiply or divide both sides by a negative number, we must reverse the inequality symbol. It's the number one mistake that students make when solving inequalities. You got to remember that you have to flip the symbol if you multiply or divide by negative. And we can express answers graphically and using interval notation. Okay? Now, interval notation is this, and this is new. Interval notation rules, you need to write these down. Our interval notation rules are as follows. The numbers in your interval notation must be ordered left to right from smallest to largest. Must. Even in the compound inequalities that we're going to look at tomorrow, they must be ordered from smallest to largest. You can't put the bigger number on the left, excuse me. You have to go from smallest to largest from left to right. Excuse me. Okay? Less than and greater than and infinity always get parentheses. And this is going to make a little bit more sense once we put it into context. Less than, greater than, and infinity always get parentheses. Less than or equal to, or anytime there's an equal involved, you always get a bracket there. Now what we mean by bracket is this hard symbol, bracket. That's a bracket. Okay? Everybody have those written? All right, so let's look at a couple of examples. Here is x is greater than 3. Now that's an answer, right, for an inequality. We can express that as an inequality. X is greater than 3 is an acceptable answer. How would I graph that answer?
Put an open circle at x.
Open circle at 3 and shade to the right. Yes. So that's an open circle at 3 and shade to the right. So that's what our graph of that inequality would look like. And here's what the interval notation would look like. Is everybody watching? Because we have an open circle, just a greater than, 3 is my starting point, right? And I go how far? all the way to positive infinity, right? It just goes forever to infinity. So the interval for this would be from 3 to infinity.
Yay.
Actually, that makes some sense.
Okay? Now, following our rules, because it's just greater than, it's not equal to, we get a parentheses on the 3. And I promise this gets easier and easier. It's really, really simple to do. You ready for another one? X is less than or equal to negative 2. Yeah, Mac?
We don't have to know interval notation till algebra 2, right?
I'm probably not going to. Well, I may quiz you or test you on it. It's really not that difficult.
Well, it really is.
X is less than or equal to negative 2. That's an acceptable answer for an inequality. What would the graph of that solution look like? Closed circle at negative 2 and shade everything to the left. Okay? So, anybody want to take a guess at what the interval notation would be?
Negative to infinity.
Negative 2, negative.
Infinity, negative.
Say it again, Robert.
Infinity, negative.
All right, which infinity?
Negative.
Negative infinity to negative 2 is correct. All right. Now, here's the kicker. Because we have an equal sign, there has to be something about our interval to show that negative 2 is included in the solution. When we're graphing, we use a closed circle to show that it's included. When we're doing interval notation, if you go back and look at your rules, what does that say? Equal gets a bracket, right? Infinity gets parentheses, equal gets a bracket. So that's the interval. Negative infinity to negative 2.
Wait, so why did you put a bracket of the last one?
Doesn't matter which one.
Because it was less than. Hold on just a second, Mac. The last one was just greater than. It wasn't equal to, so it gets a parentheses. Rule number 2 for your interval notation was what, Madison? Less than and greater than gets parentheses. Equal to gets a bracket. So less than, greater than, and infinities always get parentheses. And equal to gets a bracket. Mac, what was rule number 1 for interval notation?
They always get parentheses.
No, rule number 1 for interval notation was what? Must be ordered from smallest to largest. So negative infinity must be on the left. Negative infinity is definitely smaller than anything else. It's the smallest quantity, right? So it has to be ordered this way.
Yes, sir.
All right, so that's negative infinity to negative 2. Let's do another one. Somebody describe this solution. This is a compound inequality. What would describe x values that would work here? X can be what? What is this solution telling us?
Can be 1/2.
1/2 is certainly in there. What else would be in there? A lot of other stuff, right? Any number between 0 and 1. Is 1 included in the answer? Is 0 included in the answer? Yes, because 0 is equal, 1's not equal. So the graph of this would be, x can be anything between negative 1 and 1. Excuse me, between 0 and 1. Closed circle at 0, right? Oopsie. Closed circle at 0. Open circle at 1 and shade everything in between. So the interval notation would be bracket 0, comma 1, parentheses. Why the bracket at 0? Because it's equal to, right? Open circle at 1 is a parentheses. So this is just an introduction to a new way of writing a solution to an inequality. It won't be on the quiz. Well, we might come around to it on the next test, though. Because we'll do all of our answers from here forward. If it's an inequality, we'll do all our answers in graphing and using interval notation. Okay? And sometimes that'll be 2 different intervals. All right, solving inequalities. Really easy, right? Can we all do this one in our heads? What do? Subtract 3 from both sides. Divide by 2, you get x is greater than. Maybe we can't do this in our heads. X is greater than 3. If you subtract 3 from both sides, you get 2x is greater than 6. Divide by 2, you get x is greater than 3. All right, we're going to express our answers graphically and using interval notation. What is x is greater than 3 going to look like? Graphically. Open circle at 3 and shade to the right. Parentheses 3, comma, infinity, parentheses is correct. 3 to infinity. Right? That's how you describe that set. And 3 is not included, so we get a parentheses there. All right? How is this different from the first example? There's a variable on both sides. So when you subtract 3x from both sides, you're going to get 2x minus 2 is less than or equal to 8.
X is less than or equal to 5.
X is less than or equal to 5 is correct. Yeah. Just unwrapping the equation. Now, what's the graph of that going to look like?
Bracket, negative, infinity.
No, the graph. Let's talk graph. Close circle at 5 and shade to the left, right? Okay. And then
Bracket, negative, infinity, comma, 5 parentheses.
got it backwards.
Wouldn't it be comma, like parentheses, infinity, and then 5 brackets?
Yes. Which infinity is over here to the left, though? Yeah. This thing is getting small without bound. It's getting smaller and smaller. It's going to negative infinity. That's an ugly infinity. I'm sorry. Okay? It's going to negative infinity, right? So the solution is going to be from negative infinity to 5. Negative infinity. Infinity always gets parentheses. Why is there a bracket at 5? Because it's less than or equal to 5. All right? That's not difficult, right? Okay? 9 minus 3x. 9 minus 3x is less than or equal to 21.
Negative 3x.
All right, we got to be careful here. Why do we have to be careful here?
You got a minus 9 from both sides.
Because you get to flip this thing because 3 is here.
Yeah, I've got a negative 3x, so I'm going to be flipping the symbol, right? Another reason you have to be careful is somebody already said it. Somebody said we need to add 9 to both sides. Is that correct?
No, you need to subtract it.
We need to subtract 9 from both sides because 9 is positive. All right? Do not make that mistake. The sign in front of the number goes with the number. That negative belongs to the 3x, not to the 9. 9 is positive, so to get rid of positive 9, we have to subtract. What's another way you could write 9 minus 3x? Negative 3x plus 9. Right? So the 9 is being added to the 3x because it's positive. It has a positive value. So we would subtract 9 from both sides. And then we are going to have to remember to flip the symbol because we're about to divide by negative 3. I feel you, Greg. I'm right there with you, man. Nodding. I'm sleepy. I've been asleep at this time the last 3 out of the last 4 mornings.
5 days in a row. 4.
Yeah, oh, bless your heart. All right, divide both sides by negative 3. Flip the symbol. X is greater than or equal to negative 4. Graphically, what's this going to look like?
Closed circle
Closed circle at negative 4 and shade
to the right.
to the right. All the values bigger than negative 4, right? So shade to the right there.
And then would be like bracket negative 4, and then
Bracket,
parentheses.
negative 4, comma, infinity,
Oh,
parentheses. Yeah.
And that's it.
That's it. See, interval notation's easy, right?
Yes. If you know how to do
Which we do.
it. I'm just
Tired too, Mac. All right.
no disrespect towards you. Oh no.
Now, what do you notice right away here?
It's not true. No, it's not true.
The variable is going to go away. It might be true.
No, it's definitely
Might be false.
It's false.
Okay? But we should notice that we have parallel linear expressions here. That's special case. That has special case written all over it. If this were an equation, we could stop right here and say there's no solutions. But because it's an inequality, we could still have a true statement. All right? So what would those steps do? What are we going to do to solve this? Subtract 3x from both sides. And when we subtract 3x from both sides, the x's are gone. And we're left with negative 4 is less than 2.
And that's true.
That is true, isn't it? So what's the solution to this equation? Inequality, rather.
Nothing. A negative 4
The solution's all real numbers, right?
Oh, yeah.
But
No matter what you put in for x, negative 4 is always less than 2. So the left side will always be less than the right side. This inequality is always true.
I thought, oh, I'm sorry, I thought it was the other way around.
Yes, always true, right? Negative 4 is less than 2. Anytime something is always true, that means the solution is all real numbers.
Is that all we put?
Yes, but we're going to graph it and do the interval notation for it.
But how can
How do you graph all real numbers?
you
Just put a line and say it's good.
You shade the whole number line, right?
okay.
The number line is the real number line. So if we are having a solution that is all real numbers, to show that solution, you graph the entire real number line. Okay? And if we graph, let's see if this is on here. I don't think it is. But if we graph the whole number line, we'll do this here. We're going to shade the whole thing. Everything gets shaded. That's everything is shaded, right? Every number works. What would that interval notation for all real numbers be?
Infinity?
Maybe not.
Negative infinity to
Infinity?
positive infinity.
Oh no. Oh no.
Yeah. It's everything.
Well, I mean, that's true.
All positive and negative real numbers. We go from negative infinity to positive infinity. Sorry, my infinities look like eyes. That's just how I do my infinities.
Chris Hodge.
So I'm looking at you.
Is that it?
No. We're going to complicate it a bit. Let's move faster.
Shock. Well, we got time and you don't have that.
4 times x minus 2 is greater than or equal to 2 times x minus 4. First step, distribute. Distribute to 4, distribute to 2. On the left, we get what?
4x minus 8.
4x minus 8 is greater than or equal to 2x minus 8. First step from here is what?
Subtract.
Variables first. Variables first. If you do the number first here, you get very, very confused. Subtract 2x from both sides. And that gives us 2x minus 8 is greater than or equal to negative 8.
Well, it's going to be 0 in a second.
Then what? Add 8 to both sides. And be careful. Don't hate on 0. We have a variable still. We're going to have a solution. Divide both sides by 2. We get x is greater than or equal to 0. All right? Greater than or equal to 0 is a closed circle at 0 and shade to the right. Interval notation for that would be what? starting at 0 with a bracket. We'll go to infinity, and infinity always gets parentheses. So 1, 2, 3 ways to express the solution to this inequality. All right?
Are we going to complicate it? Yes, we are. Of course.
Do what? What are we going to do here, Carson?
Get rid of fractions.
Our instincts have to start kicking in here, guys. If we have fractions in an equation, we are going to multiply by a common denominator to get shed of those fractions. Multiply by 10, right? If we multiply each term by 10, 10 there, 10 there, 10 here, 10 here, we can cancel and simplify this thing, and we're in good shape. 2 goes into 10 5 times, and that leaves us with 5x. 5 goes into 10 twice. 3 times 2 is 6. 5 goes into 10 twice, and 2 times x is 2x. 2 goes into 10 5 times. Negative 3 times 5 is negative 15. Easy peasy. Okay? Then from there, what is it? Subtract 2x, add 6, divide by 3. We get x is less than negative 3. What's that going to look like graphically? Open circle and shade to the left. What's the interval notation for that? Negative infinity up to negative 3. Everything's parentheses, right? Open circles get parentheses. Closed circles get brackets. So that's the 1, 2, 3 ways you can express your answer to this problem. All right. I think there's one more of these. I'm going to let you try it yourself, and then we'll... No, there's not one more. There's this one.
We just tried this one.
What do you do here? What's different about this compound inequality?
We have to do it on both sides.
You have to do it on both sides, right? So we add 3 to everything. All 3 pieces get a 3 plus 3. Some of you forgot that on the last test. You just did it to 2 pieces. That's a problem. Excuse me. It's first days back from holidays. On the left, we get negative 9. In the middle, we get 3x. On the right, we get 12. Divide everything by 3. We get negative 3 is less than or equal to x is less than 4. Okay? And what do we do with that? Interval notation. Smallest value is negative 3. Closed circle, open circle at 4, and shade everything in between, right? Interval notation would be what?
Negative 3, 4.
Bracket, negative 3, comma 4, parentheses.
Okay, good. I was actually right.
Yeah.
I didn't know.
Closed circles, brackets, open circles, parentheses, infinities, parentheses. They have to be smallest to largest. And it's really simple. Interval notation is really a simple process. This one's weird.
Should we try it or not?
It's okay. I don't want you to do this. This is okay. I think we're good here. I think this is where we're going to stop.
That's not a homework.
No, that is not your homework. That's college algebra homework.